I now would like to write down, in most general form, the equation for the position and the velocity as a function of time for a one-dimensional motion whereby the acceleration is constant. So it's going to be one-dimensional again, and we have a is going to be a constant. And so the equation that I write down is the most general way that I can write it down. So we're going to get x equals some number c1 plus some c2 times t plus some c3 times t squared. And notice, oh, I already erased my example. My example is gone, but you would have seen this was an 8 before, and here we had, what did we have? We had minus 6t, and we had plus 1t squared. So you recognize these three. I can now take the derivative, and so I get c2 plus 2c3 times t, and then I get the acceleration equals 2c3. And now we get some insight into these quantities. Clearly, x1, c1, is the position of x at time t equals 0, for which we often write an x0. Because when t is 0, that is where x is. c2 is really the velocity at time t equals 0, because when t is 0, that's when c2 is v. And the acceleration is not changing with time, is 2c3, therefore c3 is half the acceleration. So this gives you some insight in the meaning of these quantities, and you can see, you can read now some physics in there. c1, c2, and c3 can independently be either 0, or larger than 0, or negative. Makes no difference. Each one of these combinations is a valid possibility in physics.